Hello and welcome to DCD's AI Week. I'm Alex Dickens, Content Director at DCD, and it is my pleasure to be introducing this session, which is a fireside chat with Doug Adams, CEO of NTT Global Data Centers. Now, as artificial intelligence reshapes every layer of the digital economy, data centers are under immense pressure to scale faster, denser, and more sustainably than ever before. In this session, Doug will be joining me for a discussion into the deep and rapidly evolving relationship between AI and data center infrastructure. So, Doug, really excited to be having this conversation with you today.
Well, first of all, thank you for the time. I appreciate it. And I'm really excited to be connecting and chatting today about my favorite topic, which is AI.
Excellent. Well, we've only got the 40 minutes, so hopefully we can get through everything in that time. I know there's a lot to unpack, but thank you. But by way of introducing the audience, I know NTT doesn't really need an introduction, but perhaps with the kind of headline stats, what's your footprint globally? Where are you operating at the moment? And when it comes to AI, how many of your deployments are in fact AI ready, Doug?
So great question. So first of all, a little bit about NTT. NTT Global Data Centers is the third largest global data center provider. We've got about 3,700 employees, 150 data centers in 21 different countries. Our AI footprint is pretty sophisticated, especially in the US. We, a few years ago, got the right mix of clients that were very early AI adopters. So we have about 250 megawatts of direct liquid to the chip AI inference in production within our portfolio. Less in Asia, less in India and Europe, as we haven't seen that technology really spread to the other parts of the globe. But the US, very dominant part of our portfolio is actual AI up and running deployments.
Mm-hmm. And you've led NTT Global Data Centers during this colossal period of growth. I mean, we've seen kind of AI and workloads go from strength to strength. But, you mentioned that you've got, different types of infrastructure capable of supporting AI in production now. How much of this shift have you seen over the last 3 years?
It's been amazing, like nothing I've ever seen. I've been at this 25 years now. And the conversations we're having with customers, I don't think I've had a conversation in the last year that hasn't centered around AI and the customer's movement to AI. So if you look at the published stats around AI and the importance of it and the growth of it, I think the Jensen Huang talks about how in the next 4 years, there's an expected $1 trillion of investment within the data center sector for AI. I happen to agree with that, by the way. But if you think about the magnitude of that, it's taken 15 years of cloud to reach $1 trillion of investment. And it's expected to be in the next 4 years, we'll hit that. So it's about a 4x adoption rate. And we're seeing that, by the way, within our portfolio. When we look at our absorption and we look at our offtake, 70 to 90%, depending on where you are in the globe, has been AI. So in the US, predominantly, 80, 90% has been AI. Within Europe, we're constrained on power and inventory. So we've seen probably closer to 50%. And that's followed through in Asia as well, where we're constrained on inventory. But in India, I'd say 70% of what we're seeing in our pipeline is direct AI, whether that's large language modeling or whether it's inference, different parts of the AI value chain.
Mm-hmm, mm-hmm. And you paint this global picture, and as you say, there's going to be different constraints, different rollouts in different regions. But broadly speaking, what would you say are the kind of macro challenges facing data center deployments for high density today? And are you seeing any particular sectors creating this demand in particular?
Yeah, I think the number one challenge for the data center sector in general is availability of power. Mm-hmm. It's very difficult to find land anywhere in the globe at this point that has a direct power availability within the next 2 years. So we have an entire team that is sourced globally over $1 billion worth of property in the last year that has immediate power available. And I can't tell you the amount of effort that it took to do that. And there are some parts of the globe, like I mentioned earlier, in Europe, where we just can't identify properties that have power available immediately. Some of them 2 and 3 years out. And so that is the number one constraint. I think that our industry is coming up with all sorts of interesting alternatives that will show up in the next few years that maybe aren't available today. Like, for instance, SMRs. I think SMRs will help correct this power availability issue. It's facing a lot of resistance. There's a lot of people that are hesitant to have nuclear power deployed at scale. But I think if you look in the US alone, there's a predicted 29 gigawatt gap of power availability over the next few years. We're going to have to start to deploy alternative power at scale. And solar and wind are fantastic, but they have a diurnal effect. If you look at nuclear, it really is probably one of the best options to fill that gap. And I think as much as people hate to see it, we're also going to have to fill that gap with coal and natural gas and other technologies, because data centers and AI is absolutely here. And the need to deploy it at scale is critical across the globe. And so I think to answer your question earlier, power is the number one issue.
Yeah. It's a really topical point that you bring up, and actually, as regards to, AI at scale, the power problem is obviously going to scale hugely as well. How are you seeing, data centers and grid relationships evolve kind of in tandem as they try and work together to, help bridge the gap? You gave a few great examples of different technologies that we're leveraging as well. But in terms of that kind of collaboration piece, how is that kind of evolving as data centers in many parts of the world are sort of labeled critical national infrastructure?
It varies around the globe. I think that in the US, there's been historically some resistance. And if you look at the timelines to bring up things like nuclear power, it's been 10 plus years. I think we're seeing that resistance, especially with the current administration, start to be taken away. And I think you're going to start seeing the adoption of things like SMR within the US, probably in the 2030 timeframe is my guess. I think that in other parts of the world, in Asia, we're starting to see potential for deployment of alternative power. I think that in Europe, it's still a very big issue. And I think people are very concerned about how power is being used and where it's being used. And so power is probably most critical within the European market. Now, there are areas like the Nordics where they're exploring alternatives using wave energy motion, things of that nature. And I think that they're doing a really good job being super progressive. The message I say is that globally, the power utility companies and the countries are becoming much more engaged at a level that I have not seen in my 25 years of doing this, because they understand how critical AI is. And really right now, I liken AI to really almost being an arms race. Every country is looking at sovereign clouds. Every country is looking at trying to be ahead in that race, because I think they understand that when we truly get to agentic AI, when we get to the point where AI is self-thinking, sentient, whatever you want to call it, I think that the person who gets there first is going to see that incredible dogleg effect. I mean, the incredible surge in AI capabilities. And so everybody's trying to be the first one there. And so countries across the globe are embracing this power issue and are working, I think, much closer with data center companies such as ours to address that issue.
What other strategies are being undertaken by utilities, by governments, by digital infrastructure providers to, approach power differently? As we see demand for mega campuses, dare I say, AI factories, and obviously, we've discussed these mounting pressures around decarbonisation as well. As there's a few different fundamentals to manage as we see this huge build out.
So let's unpack that question, because there's a lot of different pieces there. First, AI factories. I think you used the exact right term, because if you look at a traditional data center, which is racks of servers versus an AI factory, AI really requires the entire building to be harmonious and controlled together versus a standard infrastructure. The infrastructure we've used for the last 25 years has all been air cooled, and you have a high ability. You're able to plug and play servers and move servers around and move the infrastructure around, because it's just about redirecting airflow. And so very easy to rearrange, upgrade data centers. When you're looking at AI factories, you're looking at typically direct liquid to the chip cooling, which you have to have 12,000 pound CDUs placed throughout the facility, and then you have to have glycol piping going to racks. What I just described is not highly adaptable. Once you put it in place, it's going to sit as it is for many years. So you have to have, to some degree, future-proofed, and you have to understand that all the pieces of the data center work together harmoniously to create that factory. And so I think that's a very key piece for people to understand, that data centers of the future are not the data centers that we've had in the past. The technology and the amount of density and the heat produced by GPUs is much different. Even if you're looking at the disruptive technologies like DeepSeek and others, which will drive down those densities, I think you're still going to see heat use and the effects of the heat produced by the infrastructure growing over time. I get quite a few people asking me, well, DeepSeek, isn't that going to allow you to use standard CPUs instead of GPUs? And yes, there will be disruptive technologies that allow for CPUs to continue to be used. But overall, we're seeing a doubling of AI about every 12 to 18 months. And those densities are going to increase over time. And so I think factories is the right word. I love the fact you use that. As far as what progressive companies are doing to address it, I think there are tailwinds and headwinds on the power side. I think that there are still some communities that are concerned about having data centers as neighbors. And so this industry is doing things like putting up screening and making sure that the noise levels are acceptable for neighbors. I know we spend a lot of time as a company trying to ensure that we are good neighbors to the communities that we're in. And we're also working very closely with the communities. In Germany, we use our excess heat to heat over 1,000 homes for one of our facilities. We're doing things like that progressively all across the globe. In UK, we're using reverse osmosis, which has reduced our water radically. If you think about direct liquid to the chip and the savings in power associated with it, because remember, PUE is standard now, probably 1.25, 1.3 across the globe. Used to be closer to 2. But that power utilization efficiency is very important, because if you can reduce that by 5% by using direct liquid to the chip, which you can reduce at least 5%, maybe 10%, if you have a 100 megawatt facility, that's taking 5 megawatts off the grid. That's the best power savings you can ever have, right? Reducing power is fantastic, but taking it completely off the grid, that's the best way to do it. And so I think that those are a few examples of how our industry is trying to be more progressive and work better with communities. And through cost through power saving, collaborate with the grids and collaborate with municipalities to reduce power overall. Long answer. Hopefully I got most of your question.
No, you hit on a load of great points, and I've spoken with your colleague Constantine before, who spoke about how NTT kind of give back to the grid to sort of avoid brownouts in places like California. So there's really, really nice examples there. As you were kind of rounding out your point, I was thinking about kind of adaptive power infrastructure, but it's more than just power, right? To your point, there's cooling, and in this day and age, liquid cooling is becoming pretty much an essential for many workloads. Now, I know you mentioned that you've been doing liquid cooling deployments across your network for quite some time. I suppose in many ways you're quite early to the party when it comes to liquid cooling deployments. Could you explain a little bit about what that looks like at NTT?
Of course. Yeah. I like to use the analogy that we fell out of a tree 3 years ago and we hit every branch, some of them multiple times, because that's how I can direct liquid to the chip versus air cooled. We've all data centers will be air cooled for 25 years. I think everybody globally has that mastered. Direct liquid to the chip is a much more it's a much different technology. And it requires a different supply chain. It requires different expertise. It requires different engineering. I remember when we first deployed it 3 years ago at scale. It was a 60 megawatt deployment in Hillsboro, Oregon. And I remember when we did it, we didn't have test equipment to even test the racks to see if the pressure was correct. So we had to develop our own test equipment. It's different. It's not standard air-cooled data center. And so it's taken a lot of time and effort to, I think, collaboratively work with our large clients that were early adapters of this technology. And I think we've helped set some of the standards for it. What we're seeing today, by the way, as far as is rack densities, is around 150 kW to 200 kW per rack on the high end. We're sourcing to over a megawatt. And so I think megawatt to 1.5 megawatt racks will be here in the next few years. The form factor will change. They're not going to be the 60 or 80 centimeter racks we see today. I think they're going to be much bigger than that. But those racks will be in deployment over the next few years. And so it's an interesting journey. And I think it's been a journey where a lot of companies in our industry have gleaned a lot of knowledge that I think is really important.
And the perhaps obvious question, how easy is it going to be to move from air-cooled solutions to liquid-cooled solutions? When we do get to a point where these become a non-negotiable, and as we've discussed, you guys are kind of ahead of the curve in terms of these deployments. But surely everyone else is going to catch up at the same time. There's going to be a sort of onslaught of issues which are quite similar. So we're trying to do all of this, at pace and at scale. How are we going to get over that sort of head bump?
So great question. And I know we will all get there as an industry. And I think that there are a lot of very progressive players that are already there like us. And nothing we're seeing is full direct liquid to the chip. It's all mix. And you have to have network equipment, you have to have storage, you have to have things that use standard air cooling. And so the mix we're seeing now is 70-30, some instances 50-50, sometimes it's up to 80, depends on the client that we have. And those are the kinds of things you have to account for. I talked earlier about standardization. There really is no definitive standard today that you can refer to as far as water cooled is concerned. I think NVIDIA, we've worked with them over the years to help develop what is their standard today. I think that it's an evolving process, and I think there are other providers out there that have different competing standards. And so standardization is really, in the data center business, incredibly important. And without that level of standardization, we incur incremental unnecessary cost. And so standardization really is critical for how you run a data center. And I don't mean the same building and the exact same infrastructure pressed out. I mean standards in how you assemble, standards in how you cool. It's absolutely critical. And that's the biggest issue I'm seeing right now with the direct liquid to the chip is the lack of standardization. Every client wants to come in and have their own standard, which unfortunately drives cost up. Mm-hmm. So time, I think we'll see that start to decrease, and we'll start to find some natural standards that hopefully will be deployed across the globe, and that will be incredibly important for our industry. The other issue, of course, is existing data centers versus greenfield data centers. Greenfield data centers are much easier, and that's where the 250 megawatts I referenced earlier of direct liquid to the chip that we have in production in our data centers was all greenfield, which is much easier than going back and adapting legacy data centers. As I said earlier, CDUs, are 12,000 pounds. They're 12,000 pounds. You can't just put that in a multi-story, multi-tenant standard data center. You have to plan for it. Some cases you can't put them in at all because there's too much floor weight. You sometimes have to use sidecars. So it's coming together. It's coming together slowly. I think it's one of the inhibitors for why we haven't seen as much AI deployed as maybe we should, is the fact that in a lot of places of the world, the high density power is not available. And the cooling technology for legacy data centers isn't there yet. So we're waiting for new greenfield data centers to be built. Mm-hmm.
Yeah, you make a very, very valid point. How, from your perspective in that case, given that we've got, scale to deal with, nuance to deal with, as well as, these other kind of imperatives like the power constraints, sustainability challenges we've already kind of addressed. What would you suggest is perhaps the best road for operations looking to bring AI workloads into their workflow, given all these different infrastructure requirements we need to consider at the same time? Where's the kind of logical place to start, and what questions should you be asking yourself?
I think the number one question that I think customers should be asking providers is, what's your experience in doing this today, and what's your roadmap for the future? Because today we're at, standard racks being deployed in cloud infrastructure is 10 to 15 kW per rack. It's still very low density. Mm-hmm. AI today is probably around 50 to 100. I said earlier we're doing 150 to 200, but the future will be megawatt racks. So can the data center that you're moving into handle that level of heat load, that level of weight load? Mm-hmm. Is the technology there so that 5 years from now, 10 years from now, you're not obsolete? I think that is the number one question that customers should be having with their providers is, how much experience do you have in doing this? Have you actually done it before? Do you have an AI-ready data center, or have you deployed that infrastructure? Yeah. And then how do you handle the future? What happens 10 years from now? Is your data center still going to be prepared and ready for that level of heat load? And by the way, I don't think anybody has all the answers for that today. But I think we're all as an industry looking that direction and understanding that that's where we need to be.
So we're talking standards, as you mentioned. We're talking, kind of openness. We've got kind of nuance, but also perhaps a more modular, incremental approach to adapting and building things out.
Yeah, I think that's really key piece. I think modularity is very important. I think different data centers have different ideas about this. I can tell you we modular or stick build depending on how quickly we need to stand up the infrastructure and where we are in the world, because you can't modular build everywhere. And sometimes when you're sourcing to timeline versus cost, There's a difference. Modular can be more expensive, but it also can be much quicker, and allows you to build and then merge the mechanical and cooling in as you're building the building. So there's some time advantages to it. I think those are the kinds of things that the industry struggles with a bit. Generally speaking, AI deployments take a bit longer because once the building's built, you've got to retrofit with the CDUs. You've got to the customer has to have very defined standards of how they want to have it built out. It's not just, how many racks do you want to deploy and where do you want to have your network drops? Mm-hmm. It's a little bit different when you're talking about a very static infrastructure that you put in place with glycol piping that's delivered to the exact location it needs to be for the servers. So it elongates your build cycles, and then you have to be very careful in how you plan. And you need to go in with when we talk to our customers, we spend a lot of time up front understanding their exact requirements and exactly where their infrastructure will be, what type of infrastructure they're deploying, and how we're going to work with them to get that in place, versus just handing them a blank slate and saying, okay, go do it. Mm-hmm. It's very important to understand that up front. From an ROI standpoint, generally speaking, we find that AI data centers have a higher ROI. They're more, it's very verticalized solution that needs to be designed and managed in a way that is at a higher standard than a regular data center. And they also are more costly. Obviously, when we retrofit and we put the cooling component within a data center, depending on the size of the data center, it can be anywhere between $50 to $150 million to deploy that. And obviously, we're making a profit of that over the lifetime of a data center. So generally speaking, it has a higher ROI for us. So we find it very, very attractive.
Yep. Yeah, absolutely. I guess, by way of final question, as we sort of kind of run down the clock, Doug, I know it's been a bit of a whistle-stop tour, but, fundamentally, what would you say is NTT's biggest focus when kind of looking towards building out AI for the longer term as well? Obviously, you've kind of given us a really nice view on how we can adapt, but for you and your organization, what are those kind of big priorities and how are you going to continue to proactively address them?
So from an NTT viewpoint, ensuring that we have a continuous portfolio of product in the right locations to meet our customers' objectives, I think is the most important piece. So we spend a lot of time on site selection, ensuring that we have the power availability, ensuring that we're properly land banked, ensuring that our supply chain is fully charged, and that we have a proactive, prescriptive design that we can bring to our clients, because most of our clients don't have that today. They talk directly to the chip and deployment of AI, but they don't really understand what it takes to do it. Because we have 3 years of heritage of doing it, we've got a very well-designed package that we can take to our clients. So that is really where we're focusing in on, is to try to hit the easy button for our clients and make those deployments at a global, at scale level easy for them. And so that is really where most of our focus is concerned. Now, there's another entire part of NTT, because I represent NTT GDC, which is our global data center portfolio, but we also, the greater NTT has incredible value that we bring to our clients in the form of incremental service solutions. Mm-hmm. So we can do GPU as a service. We have full security services. We have highly verticalized IoT services. We are working with, can't mention the exact events, global sporting events, as well as large major global cities, mm-hmm. to create AI and digital solutions for those cities and for those large global sporting events. And it's really exciting as a data center company to be directly involved in those conversations and working with them. And those are other things that, by the way, we bring to the table for our clients because they have availability and all that. So it's fun. It's an exciting world. We're very focused on AI. On top of that, our standard core cloud business and enterprise business is also growing very strongly. As I said earlier in the conversation, most of our AI traction is happening within the US and India. We also have extraordinarily strong enterprise business within Europe, and we're starting to see AI come on. And within Asia, we have a lot of retail as well as enterprise. And again, starting to see AI come on strong. That's the nice thing about looking down at a global portfolio, is we are able to handle all different customer classes across all different regions and balance out the extraordinary exuberance that we're seeing in AI right now in the US with our global enterprise and retail businesses.
Amazing. And, you see that kind of patchwork of best practice use cases and what the standards can be going forward, I suppose.
It's fun. It's a great industry to be in. It's a great time to be in it.
For sure. Well, Doug, that kind of brings us to the end of our conversation. I know you've got a very busy schedule, so I appreciate you hopping on to have this conversation with me, and really appreciate yours and NTT's perspective here.
Thank you. Appreciate your time. Hope you have a great afternoon.
Yeah,
Bye-bye.
Likewise. And hopefully see you again another year's time to see what's changed and where we're at in terms of kind of AI deployments.
That'd be awesome. And by the way, thank you for all the great things you're doing for our industry, getting the news out, making sure everyone understands what people do within our industry and what the latest trends are and where things are going is incredibly important. So thank you for everything you've done. Bye-bye.
Well, we really appreciate that. And thanks to you as well. To our audience, thanks to you also for tuning in. I hope you enjoyed that episode. If you do have any questions, please reach out to Doug, NTT and the team. They would love to hear from you. That's all we've got for day one of AI Week, but we'll be back at 2 p.m. Eastern time with more episodes tomorrow, so you can continue the conversation then. Thank you.